Good afternoon or morning, whenever you're watching this. This is the Trig review for the quiz in the fourth 9 weeks over trigonometry. So I'm going to go through one portion of this pretty quickly, and if you're having to study for this, it'll be here available to you. So first of all, you got a little quiz over this. It's very, very similar to these problems. So what you see here should be, very much what you need to study in order to prep for this properly. So 120 degrees. Okay, if I'm going to graph that, remember, I'm always starting from right here. That's 0 degrees, right? If it's positive, I'm going this way. If it's negative, I'm going the other way. So we're going to go, obviously, from, we're going to go counterclockwise 120 degrees. So that's past 90, about 30 degrees. So that's going to get me somewhere around in here. Again, your graph doesn't have to be absolutely perfect, but it does need to be right. See, this right here is 120 degrees or so. Okay? Okay, here we got negative 50. Again, like we just talked about, always starting from 0. And since this is negative, I'm going to go clockwise 50 degrees. So that's going to put me somewhere around in here. All right? And then finally, 400 degrees. So remember, it's positive, so we're definitely going around. And if I go all the way around, that's 360. So it's past 360 degrees. How far past 360 degrees? Well, if I subtract, and most of y'all can do that in your head, that's 40 degrees past. So here's about 40 degrees past 360. So that would be the location of a 400 degree angle. Okay, very simple. Hopefully you guys will remember this. Now, as far as converting, we talked about how you can convert from degrees to radians, radians to degrees, using the same thing. You just got to flip the fraction, and that was pi being equal to 180 degrees. So if I'm going to change 150 to a radian, I'm going to multiply by pi over 180. And then, of course, the trick to that is just to ignore the pi. You're just going to bring the pi down kind of like it's a variable. You're going to ignore the pi and just let it come on over here and sit. Got a little lag going today. And then you're going to go to your calculator and you're just going to tell it, hey, I want to take 150 over 180 and let it simplify. And that's going to be the fraction that joins your pi, so 5 over 6. So my radian measure to be equivalent to 150 degrees is 5 pi over 6. See, I just took that fraction and I let pi kind of join it. Now 150 degrees is represented as a radian. So same thing here. We're going to multiply by pi over 180. We're going to do the same thing where we just let pi come on over, and our focus becomes negative 225 over 180. Let that calculator do all the reducing for you. So that's negative 5 over 4. So we're going to write that as negative 5 pi over 4. And then the last one, where we're going in that direction, we're going to multiply again by pi over 180. That's our conversion. We're going to let the pi come on down. Again, you've got the hang of this now. And we're simply going to take 300 and put it over 180. Let that reduce, and our answer is 5/3. So we're going to write this as 5 pi over 3. So that's how you can convert a degree to a radian. Now let's flip that. Let's go the exact opposite direction. Let's now go from a radian to a degree. And again, it's the same value. Pi equals 180. So here we're going to multiply by, instead of pi over 180, we're going to multiply by 180 over pi. Now hopefully this makes sense, because remember, if I'm trying to change it from a radian to degree, what do I need to cancel? Well, I need the pi to cancel. And sure enough, if pi is on the denominator, then it's going to cancel with that pi that's in the numerator. So that's how I know the direction. And then I'm just going to grab my calculator, since the pi's cancel, and I'm just going to do 7 over 6 times 180. And I'm going to let it do all the reduction for me. 210 degrees. So there you have it. That's how you do it. Very simple. Look at number 8 again. We're going to multiply by 180 over pi. Pi's will cancel. And I'm going to go to my calculator. I'm going to type in 11 over 6 times 180. And that will change it to a degree. That's 330 degrees. Let's do one more. We're going to multiply that. Oops, sorry. I forgot to switch it back. That's 330 degrees. There, number 8. We're going to do one more. We're going to multiply by 180 over pi. Here's a little different. The pi's cancel, and really I don't have a number up here, but remember, it's understood to be a 1. So really this is 1/10 times 180, which gives me 18. Or I could have done 180 divided by 10, also 18. Okay, let me go back and show you. See, since that's just a 1, I could just take the 180 that's in the numerator and divide it by the 10 that's in the denominator. But either way, you get 18 degrees. That is my answer. Okay, so whether it's marking where an angle is on a coordinate plane, or changing a radian to a degree, like 7 through 9, or changing a degree to a radian, like 4 through 6, that should be a pretty easy portion on your quiz. Now, let's move along. The next thing we're going to do is talk about coterminal angles. Now, when we talked about this, we talked about the fact that if I have an angle here, to be a coterminal angle, that means it has to be in the exact same position. So it has to land right on top of itself. So what causes two angles to be what we would call coterminal? Well, it goes all the way around the coordinate plane. Well, what is going all the way around? Well, it's 360 degrees. So what we're going to do to find coterminal angles is we're going to add 360 degrees and we're going to subtract 360 degrees. And that will find two angles that fit in the exact same location, but one more positive from this being a positive one more positive one, and then this will give me my negative one. So I'm just going to go to my calculator. 75 plus 360. Whoops, didn't mean to put that. And that will give me a positive angle of 435. And then I'm going to do 75 minus 360. And that will give me my other coterminal angle, not just two of them. Remember, I could do as many coterminal angles as I would want. I would just have to keep adding or keep subtracting 360 degrees. Okay, that's the deal. 75 and 435 and negative 285, all in the same location. If I graphed them, all of them would be in the same location. So that's what we're talking about when we deal with coterminal angles. All right, number 11. Since that one's negative, we need one positive one. So we're going to take negative 115 and we're going to add 360. That'll give me a positive one. But we need one more negative one. So again, I'm going to take negative 115 and I'm going to subtract 360. So I'm going to get my calculator and let it do its work. Negative 115 plus 360 will give me a coterminal angle at 245 degrees. And then one more at negative 115 minus 360. And that is negative 475. So that's about as easy as you can make a problem. Honestly, you're literally just adding and subtracting 360 because it gets it all the way back around. And the last one, 250, is positive, so we need one more positive one. So we'll add 360. And we'll need a negative one, so we're going to subtract 360 as well. Same thing on all of these problems. So 250 plus 360 gives me a coterminal angle at 610 degrees. And then 250 minus 360 gives me negative 110. Okay, so let me go back where you can write those down if you didn't catch them the first time that I did it. There they are. Very, very simple concept. Okay, now a little bit harder conversation has to do with when we're dealing with theta in a coordinate plane, when you have an x and a y. We said that x squared plus y squared will equal an r squared. So basically, in a nutshell, here's what we did. We created, by going a certain distance on x and a certain distance on y, whether it's up or down, left or right, and we created a right triangle by connecting that endpoint to the origin, and see how that creates a right triangle where you have x here, you have y here. So if I'm always, let me zoom in on this, if I am always finding theta, which is created at my origin, then x right here will always be my adjacent leg. Y will always be my opposite leg. And that leaves one more value, and that value is r, which is my hypotenuse, okay? Or technically, thinking about circles and how this compares to circles, that would be my radius. That's where r actually comes from. So with that being the case, we compare this then to SOHCAHTOA. Remember, this is always the trig functions, and since x stands as my adjacent leg, every time I think about x is going to go in A's position. And then, of course, y is my opposite leg. So every time I see y, it's going to go in O's position. And then, of course, when it comes to the final thing, r is your hypotenuse, so that will always go in H's position. So sine is always y over r. So therefore, cosecant will be r over y. Well, cosine, adjacent over hypotenuse, will always be x over r. And therefore, secant will be r over x. And then finally, tangent will be opposite y over adjacent x, y over x. And then cotangent is the reverse of that. It will be x over y. So that's the values that we're going to be utilizing when we jump down in here to a problem like number 13, 14, and 15. Now 15 is a little different than 13 and 14, and we'll talk about that in just a minute. But if you look at this one, here's my coordinate plane, okay? And if you notice here, I probably should do this a little lower. There you go. It goes left 4, right? X is negative 4. So I go this way. I go 4 to the left. It's negative 4. And then y is positive 3. So I go up 3 here. And there is the triangle that is created right there, where theta, of course, is always the angle created at the origin. So again, opposite leg is 3, adjacent leg is negative 4. All we need to find is my hypotenuse, my r. So I'm going to do that by simply going 3 squared plus, and in parentheses, negative 4 squared equals r squared. Of course, 3 squared is 9. Negative 4 times negative 4 is 16. That's 25 equals r squared. We're going to take the square root of 25, and my radius is 5. Okay, so now I can answer whether I use SOHCAHTOA or I use all of these fractions that are here, I should be able to understand how to write these no matter which one I use. Whether I use SOHCAHTOA, like we said, or I use these fractions. Because if you look at them, it's the same thing. Look, theta for sine would be opposite y over hypotenuse r. That's exactly what it says. So I can use either one of these. They're interchangeable. So visually, I like to look at this one and use SOHCAHTOA. Sine is from theta, right here, opposite, that's 3, over hypotenuse, 5. Cosine is adjacent, that's negative 4, over hypotenuse 5. And tangent is opposite 3 over adjacent negative 4. And I usually just put my negative out in front. You can put it in the denominator, it doesn't really matter. And then when I do all these others, I just flip my fractions. So I got 5 over 3 here. I've got negative 5 over 4 here. And I've got negative 4 over 3 there. And that's it. It's done. Okay? So if I look at number 14, let me do my coordinate plane. This one is going left 12. So negative 12 this way. Then it's going down 5. Negative 5 this way. And then the angle that's created, the triangle that's created, is from that point where negative 12, negative 5 ends back to my origin. And then that is the location of theta. Now, just like the last problem, I need to find my r. So that's negative 5 parentheses squared plus negative 12 in parentheses squared equals r squared. Now, maybe you can't do that one in your head, but I'm going to type in negative 5 close parentheses squared plus in parentheses negative 12 close parentheses squared. And when I calculate that, it's 169. So 169 equals r squared. I'll go back to it in a second. We always take the square root. So I'm going to take the square root of 169, and that value is 13. My radius, my hypotenuse, if you will, is 13. So now, whether I use those fractions or whether I use SOHCAHTOA, I can figure this out. From theta, the opposite leg is negative 5 over the hypotenuse, 13. Cosine's the adjacent leg, that's negative 12 over 13. And then tangent is the opposite leg, negative 5, over the adjacent leg, negative 12. And those, of course, will cancel and become positive 5 over 12. Now flip all those. Cosecant is the inverse of sine, so it's negative 13 over 5. Secant is the inverse of cosine, so that's negative 13 over 12. And finally, tangent is the inverse of, or cotangent is the inverse of tangent, so that's 12 over 5. So there you have it. Very, very simple task. Okay, last one, and that is a little different. Here's my coordinate plane. This one actually does not go left or right. Look, x is 0. And did you hear what I just said? X is 0. Now, y does go up 4. So y is 4. And now think about it. If I took 0 squared plus 4 squared equals r squared, that's just going to equal 16. I take the square root, and sure enough, r is the same thing as y in this case. Now, there is an exception sometimes. If I went left 4, x may have been negative 4, but r would have been a positive 4. If I'd have went down, y may have been a negative 4, but r would be a positive 4. Your radius has to be positive. So here's the deal. In this case, since you can't visualize it the same way that we visualized the last problems, since you can't see your opposite leg, your adjacent leg, and your hypotenuse, this is when I would encourage you to rely on the fractions. Remember, the opposite leg is always y. So y opposite over r, 4. And that's going to equal 1. If you flip that, it's still 1. Cosine is adjacent leg, which we said is always x. So that's x over your hypotenuse, which is r, 4. That, if you type in your calculator, will equal 0. But if I flip that, 4 divided by 0 is undefined, which you need to say that. You can't just tell me it's 0. 4 divided by 0 is not 0. It's undefined. And then tangent is y over x, okay? Opposite over adjacent, so that is 4 over 0, which again, undefined. And cotangent flips that, so cotangent is 0. All right, I'm going to do one more of these because you're going to be dealing with some radicals, and I just want to clarify my expectations. So this one is going 7 to the right, it's going down to, it's creating this right triangle where there's my 90-degree angle. So right here is my theta. So I'm going to type in 7 squared plus negative 2 squared equals r squared. So let's go see what that is. 7 squared plus, in parentheses, negative 2 squared is 53. We're going to take the square root of 53, and 53 is not divisible by any perfect square. Okay, look, if I tried 25, doesn't work. If I tried, not 63, if I tried 16, doesn't work. If I tried 9, doesn't work. And if I tried 4, doesn't work. So it's not divisible by any perfect square. So I can't simplify this. So r is the square root of 53. Okay? Now, I can visualize this one. So I'm probably going to go back to the old trusty SOHCAHTOA. So, opposite, remember that's your y value, negative 2, over hypotenuse, which is square root of 53. I can flip that, and that's negative square root of 53 over 2. Cosine is adjacent, that's 7 over hypotenuse, square root of 53. So flip that, that's square root of 53 over 7. And then finally, tangent is opposite leg, y, negative 2, over adjacent leg, 7. Flip it, that's negative 7 over 2. Now, there is one thing that I told you. If you leave them like this, I'm 100% fine with it. But remember, math, for some reason, has never really liked radicals in the denominator. So you could multiply by the square root of 53 over the square root of 53, and that will equal negative 2 square root of 53 over 53. You could do that. That gets the radical out of the denominator. Here, you could multiply by the square root of 53 over square root of 53. So that will equal 7 square root of 53 over 53. So I would be okay with you doing those, but again, I'm fine with you also leaving them, even with the radical in the denominator. I know that math doesn't generally like that, but I'm not going to have a problem with it personally. So there you have it, okay? Pretty easy stuff. Now listen, that is what your quiz is over. There will be no more problems on the quiz that count for your grade other than those. Now there will be one set of problems that are a little different. They're worded a little differently. We have done them in our homeworks leading up to this, but it's a little different, but it's bonus. So if you get it, good. If you don't, it's not going to be the end of the world. Now listen, the review that I gave out had a whole nother group of problems. I'm not going to do those. It would take too much time. But here's a good review for you to follow, and that will prepare you for your trig quiz. All right? So study.